Hello and welcome back to another episode. Today we're going to be looking at Bianco Hills, the second world in the hack. As always, I invite you to join our Discord community, link in the description. This time I don't have anything to explain beforehand, so let's just jump right into the first level. The first thing you might notice is the new background. This background is not based on any model you'd see in game. I kind of took the texture from Bianco Hills and I modified it so that you can see it sort of fades into the background. That's not actually any graphics effects, that's just a texture. I had to match the texture color. If you look really closely you can actually see the bottom of each one. Like, it doesn't perfectly match up, but it's close enough. The other thing I added was I copied the models from Bianco Hills and I put them on the towers that wasn't on there in Arcade 1. I also smoothed the shadows so it looks much better. But apart from that, this level's barely changed from Arcade 1. This one's sideways and supposed to provide a slightly different challenge. The aim with most of the levels is to just introduce one mechanic and then see how far I can take it. So in this level, the whole idea is just these star blocks, and I just wanted how many ways could I change it. So at the start they're static and then they move a bit faster, now they're sideways, and now I've made them really tall, and this is pretty easy. It's the same object, you can just change the scale settings so you can stretch it in one direction. And the idea here is that you're supposed to platform, but instead of walking on the star blocks, they're actually trying to push you off, and it makes it slightly more awkward to platform, so they act as sort of an obstacle. That was the idea behind that. And then this is something I like to do a lot, is to reuse a certain block. So this block was pushing you off before, and now we're going on top of it, so it's good to like get multiple uses out of each block. Another side note is I moved the star. It used to be over there, but I moved it here so you couldn't cheese it with a glitchy wall kick, because I actually didn't know about that when I made the game, when I made Arcade 1. The focus of this level is to introduce these enemies. They're from Bianco Hills, and I try to do this a lot. I take the elements from each level. I couldn't really find a good location for the blue coin, so I just stashed it like here. It's not really anything special, but it's just like somewhere most people wouldn't look, they just run right past it, and it actually became one of the harder blue coins to find. These ones are slightly different. You can't actually kill them. You have to have flood to kill them. And another constraint with this level is the number of enemies you can have on loaded limited the length of the level, because I've actually reached the limit here. If I tried to add another one, it just wouldn't load in. One of the best parts of Sunshine modding is the script system. It allows you to write simple scripts that can implement certain behaviors in the game. For example, it is used for NPC dialogue, red coin missions, and the boxes minigame. So how does it all work? The majority of the game's behavior is controlled by the compiled machine code, which is stored in the DOL file, but some behaviors are specific to certain levels. For example, each Pianta acts differently, some talk, some ask you for money, and some chuck you. For this, each level has what's called an SPC script that runs alongside the main game. These are written in a different language from the main game and are stored in SB files. Arucus has made a compiler that can create these script files. The language is called Sunscript and is very easy to program in. I've put a link in the description to the tool you can use to compile these programs. These script files are quite powerful, and I've used them to create a variety of game modes in my hack. But the best part about this whole thing is you don't need to learn and reverse engineer complicated assembly code to create custom behaviors. The whole thing is handled by the script system. To get a feeling of how this works in practice, let's look at making a simple red coin mission with no timer. before we do anything, let's first load all the objects in place. So what do we need to make this red coin mission? So this is going to be a non-timed red coin mission, the simplest kind of red coin mission we could imagine. So let's see here. Okay, first of all, we need a shine sprite. This is going to be the final shine that spawns at the end of the game. Remember this Japanese text? We're going to need that later. So it translates to shine for red coins. That's what it translates to. Okay. What else do we need? We need the red coins. We put them all over the level. So there's one there. There's one all over the place. They don't actually need to have separate names. You can just paste them. Here they are, the 8 red coins. So make sure you have 8 of them. I like to number them so you can actually see how many you have. What else do we need? So this seems like everything, but there's one more thing we need, and we need to go into the tables.bin to see it. But the point here is that when we load the cutscene, where does it see the cutscene from? What's the perspective on the cutscene? Well, in the game, you'll see it from here, and it will show the shine sprite spawning. But how does it know to put the camera here when you collect all 8 red coins? Well, we need to open the tables.bin, and like I said in my first tutorial, there's some hidden stuff in the tables.bin. So let's see what's hidden here. Here it is. Here's the little cube that tells the game where to load the camera from. So we need one of these. Okay, this is the important one though. Red coin shine camera. It can be called anything you want. You'll see later. Just remember this name, copy it somewhere in a text file probably, and yeah. So if we wanted the shine cutscene and we wanted the camera to be like all the way up here, we'd have to put this block all the way up there. Well, I moved it miles away, but you get the point. Once you've downloaded SPC or SunScript from my link in the description, you should have a folder that looks something like this. Before we get into any of the programming, I want to run through some of these files and what exactly they mean. So first thing, you have a folder here called scripts. This is a folder full of example scripts, and in fact all of the scripts that I used in the making of Arcade 2 are included in these examples, plus a couple more. And I've gone through and I've actually commentated all of them. So this is the cops one, this is the one where they throw you off. I'll cover this more in detail, but they've all got nice comments. So if you're ever looking at how to do something, check out some of these scripts. Okay, the next thing here we have is the SPC sort of standard library, and these are files that contain all the built-in functions. So what is a built-in function? Essentially, the way to think about it is it's like the API or the interface between SSC and Sunshine itself. So let's just do this with an example. If we go into sound.sun, we've got some of the built-in functions we can do. So start BGM means start background music, that's what it stands for, and you have to pass in the ID of the background music, and I'll get into that a bit later. So if you wanted to actually do something in the game, you have to call a built-in function. So changing the background music is just an example of one of the things you can do. It's really good to look through all of these. I don't have time to look through every single function and describe it, but in the description I will link a document that I've made trying to document what all these functions do and what you should pass into them. Let's just look at some of the other ones. An interesting one is talk.sun, so we've got some more ones. We can get the NPC that we're talking to. We can get their name. We can do stuff like options when they say yes or no. That's all in here. But the best way to understand all of this is to just jump right into it. So let's look at a red coin script. This is going to be a non-timed red coin mission. So I've got one here. This is in the examples. It's called myredcoin.sun. So the first thing we do is we import SSC common.sun, and what that is just one of these files here, and it just includes all of the files we want. Also includes some types here, which is useful. Now let's go back to the script here, and let's full screen this. So the first thing we have to do is import those libraries, so that way we can use the built-in functions. This is the wrong script. Right, so the first thing we do is we call this kill shine functions, and what that does is the shine in the level is originally spawned, and then when we kill this, we give it the name of the shine. As we saw earlier, this is the name, it's Japanese, and that hides it on frame 1. So that means that essentially you can't collect the shine until we spawn it again. So it's important to do that so that the shine isn't there immediately. We have to have it absent at first, and then it will spawn in once we get 8 red coins. Okay, now we've got this while true loop, and that's essentially an infinite loop until we break out of it with some kind of break statement, which we've got here. So here we've got a line, red coins equals get system flag, and then it's got this number here. So what is this? First of all, I assume you know what a variable is, but this is a function, this is a built-in function, and it gets a system flag. What is a system flag? That's essentially a number that's in memory, and it tells you various parameters about the game. How do you know which number to put in? What does this number mean? Well, for that, we should go to Nokidoki's documentation on this. Okay, here we are at the SMS RAM map. This isn't just a RAM map, it's also got some great other documentation, but you want to scroll down on the bottom here until you reach one of them called T Flag Manager, and this is going to tell you what all the system flags represent. So essentially a system flag, each one has an ID, and each one will represent a certain state of the game. So for example, this one here, 165, that one's going to be set to true if we've collected the Rico Harbor 100 coins shine. So if we wanted to know if we had collected that shine or not, we needed to use this thing. We could get the system flag, and then we could do an if statement, see if that's true or not. In this case, we've got this number here, so let's scroll down and see what that one represents. You go down all the way to 60,000. Well, not quite because it's in hex, but whatever. So we can see here what this is it's an integer, and it's keeping track of how many red coins we have. So that's how we access the number of red coins we have. Okay, next we've got this if statement. So if the red coins is greater than 7, and because it's an integer, that actually just means 8 or more. You can use greater than or equal sign like this, but I just like to use greater than. So if we've got more than 8 coins, or technically you shouldn't be able to get more than 8, but again, I prefer doing this sort of greater than sign, because if somehow you manage to duplicate a coin and you got 9 coins, I feel like the shine should still spawn. It makes it a little bit more bulletproof. I don't know, I'm just paranoid. Okay, what does this do? Appear shine. What are these things? So you'll notice that this one is the shine name that we gave it in the bin editor, and this one is the camera that we set up earlier. And so this will be from the point of view of that camera, and then it will spawn this shine. And then we break, and what that means is we exit the loop that we're currently in. So that would mean that it goes to here. And once the SSC script reaches the end of the file, it just terminates, and it will never run. What this yield function does is relinquish control from the script and give it back to the main game. And then the game will return to the script 1 frame later. And the importance of this is if you don't put a yield function, the script will never relinquish control back to the main game. So essentially the game will just hang because it's stuck in an infinite loop. And without the yield statement, it never progresses to the next frame because the game is constantly processing this script, and it doesn't relinquish control back to the main game. So it's really important to always have a yield statement every frame, and to make sure that you can never get in an infinite loop where the script doesn't yield. It's fine to have an infinite loop where you have a yield function, because, for example, if we did this, this is totally fine, because it is an infinite loop, but it's not stuck because every time it goes through the loop, it's relinquishing control back to the game so it can progress one more frame. If you don't have the yield statement, you will get freezes and glitches. So if that's happening with your script, make sure that your yield statement is accessible. Another common mistake, we might be doing something like this. So you think, oh look, I've got a yield statement, it's fine. But what if you didn't have enough coins? It would skip over the if statement, it wouldn't yield, it would go back to the start, and it would never relinquish control from the script. So it's really important to have the yield statement, and you've got to make sure that you call that once a frame. And that's basically it for the script. Pretty simple. Okay, what about a red coin timed mission? We've got a few more objects we need to have. So Mario starts the level, he's free to roam around, but he has to hit this coin switch. So that's the first thing we need, is the red coin switch. So where is that? Red coin switch, that's a separate object. You copy that from another file, so that's the first thing you need to have. The next thing you need to have is when he hits the red coin switch, a little message pops up. How does that work? Well, secretly under the hood, what's happening is there's a signpost that's invisible, and it teleports in front of Mario, and then he talks to the signpost, and that's how the text appears. So how does that work? Well, I'll dive into that. That's all controlled by the script, but essentially we need to have this signpost. We need to give it a name. This name can be whatever we want. Just remember it for later when we're doing the script. Okay, the next thing we need to have is the 8 red coins, and again we need to have the shine sprite, remember the name, and also once again we need to have the coin camera. So now that we have the scene set up, we've got the NPC board, and this function get address from view object name. So we have the name of the board and we want to get its address in memory, and the reason we do that is so that we can pass it into functions later on. Some functions require the name of the object, some functions require the address of the object. Again, if you want to know which is which, check the documentation that I linked in the description. Next we hide the signboard so that the player can't see it, because it's only there as like a janky sort of way of making the text appear on the screen. It doesn't actually act as a signboard, so we don't actually want it in the level. Next we've got this infinite loop here, and this is quite common. We've got a lot of infinite loops, and essentially the way you're going to structure your script is if you have several stages to the level, you want to put each stage in a while true loop, and then once the condition is met to break off into the next stage, we break here, and then it will progress to the next loop. So what's this first loop doing? It's seeing if a system flag is set. And what is this system flag? Well, again, let's check the documentation here. Scroll up here, and we've got red coin switch pressed question mark, which means is it pressed, is it not? So if we have pressed down the switch, we want it to break, and that will progress onto the next stage. But if Mario is doing something else and we're waiting for him to press the switch, we basically want to just yield, relinquish control from the script, and give it back to the game, so then we can progress one more frame, and then we'll check again the next frame. Have we pressed the switch? Okay, if we have, we're going to break off to the next stage. So what's the next stage is this. Warp to front to Mario, and this is why we needed the address. What this does is it puts the signpost in front of Mario so that it's in talking range. Otherwise, I think the game would kind of bug out, or it would maybe force Mario to turn around. I'm not exactly sure what would happen if you didn't have this. This function, force talk, and this confused me a little bit. What's going on here? So essentially, force talk both returns a value and also does something. So what it does is it makes Mario talk to the NPC board, and without pressing B. So normally you have to press B to talk to something. Well, this is a programmatic way of triggering the talk event. But also it will return true if it successfully managed to do that. Because it tries to make Mario talk to the NPC board, but that's not always possible. If Mario is jumping or in the air, he can't talk to NPCs. If he's dying, he can't talk to NPCs. So there's certain states in the game where he's not allowed to talk to NPCs, and this will return true if it's managed to get Mario to talk to the NPC. So the point is essentially the way you read this is, if we manage to make Mario talk to the NPC, then proceed with this. So just doing this, you might think, okay, we're just going to force him to do it without the if statement. Well, the problem with this, if you just got rid of the if statement and did something like that, so you might think this makes sense. We warp it in front of Mario, we force him to talk to it, and then we send the message, and then we do the rest. The problem with that is, if Mario is in one of those inaccessible states where he can't talk, this won't actually trigger the talk event. Then we try and send a message through the talk event, and the game crashes. So really important to have the if statement when you're doing a force talk function call. The next we have this talk and close. Essentially just send a message. So once you're in a talk event, you want to send a message. You want to say what text should the game load, and this is what this function is saying. Messages are stored in BMG files. If you want to load a message that's stored in the local BMG file, the messages.bmg, then you need to use a different ID. I'll explain that in a bit later when we get onto the coin attack script. But for now, just remember that this code is the message that says good luck on the red coin mission, blah blah blah. It sets you on the mission. So I'm not sure exactly where to find these numbers or how you would access these numbers. I'll talk a bit more about that later, but for now just accept that this is the magic number, and if you wanted to send that particular message, you need to use this number. Appear 8 red coins and timer. So that's just a built-in function that does exactly what it says. It makes the red coins appear because originally they're invisible, and then it appears the timer, so pretty self-explanatory. Start BGM. That's start background music. And okay, what's this parameter we've passed in here? So let's go back to the standard library for SunScript, and we go back to sound.sun. So in here you've got all the built-in functions. Start BGM starts the background music, but what background music? How do we load a specific track? Well, that's where this comes in. So down here we've got all the IDs for specific tracks. So for example, Bianca Hills is this ID. So instead of typing this magic number and not knowing where it came from, we have this sort of table here, and we can load specific tracks. What is the track we're loading? We're loading BGM time event, and what that means is we just, instead of passing in this number, we pass in this. It's the same thing because they're equal to each other. Okay. Appear red coin counter. Essentially what this is that it will say 0 out of 8 red coins, because normally the coin counter only appears once you've collected your first coin, and this is just so that it appears immediately when you start the mission. Break, that means that we go on to the next phase because we're done here. Again, yield is very important. Once you have an infinite loop, you have to have a yield. That's basically the golden rule. Otherwise the game will freeze. Okay, next we've got this one, coin num 60,000. We've covered this before. This is the same thing. This one's just got a couple more leading zeros, and this is the number of red coins you have currently. If we have more than 8 or 8, then we stop the timer, which we initialized over here. There. This is where we started the timer. Now we stop the timer. Doing timers on other things is a bit different. The red coin switch, the button, has some stuff programmed into the actual game so that it sets up the timer automatically based on a parameter. How does this work? Well, this switch is sort of like a built-in function by itself. It interacts with the actual game engine and tells the game engine how much time we need to have. So there's this property down here called timer, And this is the amount of time that the game will give Mario in twelfths of a second. I don't know why twelfths of a second, but they chose that metric. So you set the time here, not in the script. So now we have to stop the background music we started. It's the same idea. If you tried to stop a background music that you actually never started, I think it might cause an error, I'm not sure. It might crash. Just don't do it. Make sure you've actually started the background music that you're trying to stop. And then we do an appear shine, which is again the same thing we've done with this. You've got a camera object, you've got a shine. You have to pass the shine first, then the camera. And then you break, which breaks out of the loop and ends the script. What if we don't have 8 coins? Then we use this get time. Get time gets the current time. It doesn't get the clock. Like you wouldn't say 8 p.m. or whatever. This is the number of seconds you have left. If that's less than 0, again, here it's really important to do a less than. Again, stop the background music. Start miss. This function just kills Mario. Rest in peace. And then we break out of the loop, and that again ends the program. So once it gets to the end of the file, it ends the program. And yeah, that's basically it. So we've got these 3 stages. We wait for Mario to hit the button, and then we wait for Mario to talk to the signpost, and then we do the main stage. So it's a little bit more complicated, but this is sort of the basic structure of most SSC scripts, where you just have these while loops to represent each individual stage of the level. And again, it's like all programming, you need to use a little trial and error, but you know, it looks a little bit complicated, but it's quite simple, really. It's quite simple. Okay, what do we need for our coin attack level? Well, again, we need a shine sprite. Where is that? Here it is. We need the NPC we're going to talk to. He's over here, and we need to give him a name. What are we going to call him? Where is he? He's down here. We're going to call him Trollman, because he's kind of trolls you. So what's going to happen in the level? Mario is going to talk to the NPC. He's going to throw them here. Again, big hitbox coins. And then he's going to come all the way over here. He's going to collect the shine. Okay, cool. Well, how do we get the Pianta to throw Mario? He has to have a special property, which is here, chucking 1. We need to set this to 1 so that he actually throws Mario. This isn't controlled by the script. This is actually controlled by the property here. So make sure you set that to 1. Okay, once we've got this set up, let's go through the script line by line. Always have to have this at the top of the file, obviously. Next we go into the first stage. So this is the stage where we want to wait for Mario to talk to the NPC. Again, we could have used a forced talk, but in this case I just wanted them to have a little look around first before talking to the guy straight up. So this is what we've got here. Okay, so the way you wait for a talk event is we have to essentially check every frame. Is Mario talking to someone or is he not? And the way we do that is we use the isTalkModeNow function. Okay, so if he is talking, then we have to get the NPC name, and this is the name we typed in. We've got to check, is he talking to the NPC we want him to be talking to? He could be talking to something else. He could be talking to a signpost. And we want to make sure he's talking to the correct NPC, so we send the correct message. In this case, there's only one NPC, so this isn't strictly necessary. But I always like to have it, because if you have multiple NPCs, as we'll see later in the game, you know, you'd have to have like an else if statement. And let's say you had another one called Troll Woman. Then it would look like that. So it's sort of like a switch statement. I don't think SSC has switch statements though, so just has to use the if else. Okay, so if we are indeed talking to the right guy, there's only one in this case, so it's fine. then we have to send the correct message. So we set the messages up in the messages.bmg file. How do we load those messages in SSC? Essentially, the messages that are in that file are loaded like this. With the first byte is first 2 bytes rather is 0002. So that's always going to be the code for if you want to load a BMG message from your local BMG file. Here, this second couple of bytes is the ID of the message. We set our ID to 0 because it was the first message in the BMG file. If we were doing the 10th message in the BMG file, we do it something like this. We put an A here. Remember that we're doing hex here, so the index has to be in hex. This would load the 10th message we put in the BMG file. Actually, this would be the 11th, but whatever. So that's how you do that. Next here we've got the warp Mario thing. So this has a X, Y, Z coordinate, and also an angle of rotation, which way Mario is facing when you warp him. The reason I put this here is so that the throw is always consistent, so that you always hit that parabola of coins. Okay, start BGM. Here we start the music. The reason I used the code here and not one of these is because I couldn't find this specific code in there, so it didn't seem to exist. But actually there it is. You know, you could use either one. It's probably better practice to use this one. So that's my bad. Okay, coin. This is the number of coins we have. Get system flag. Okay, sysf gold coin number. Where's that from? Well, that's from the standard library. So let's go back to that. SSC, and I believe that's in system. Yep, there it is. And this just stores the flag ID, and we can double check that over here. Let's just check it. Gold coin count, perfect. So that's how we need to do that. And again, this is a pretty good page there. Okay, set system flag. Okay, so we can read the number of coins Mario has, but let's actually modify that. How do we do that? Well, we use the set system flag. So first we need to pass in which argument are we changing, and then which argument, what do we want the final value to be. So we want the final value to be 15 more coins than Mario originally had, which is in this case true. Okay, the second phase, once Mario's actually talked to the NPC, we want to decrement how many coins he has every so and so seconds. So how do we do that? How do we time events? Well, we use the yield function. So here we have I equals 0. Okay, this is going to be our timer. While I is less than 190. So every time we loop this through this loop, we're going to increase I by 1. And then we're going to yield. Yield waits 1 frame. So essentially what this does is it yields 190 times. And that means we wait 190 frames. So this is kind of a janky way of waiting a certain amount of time in SSC scripts. Okay, now we've got this handy function here. This decrements a system flag by 1. Okay, now we decrement it by 1. We check the number of coins we have. Okay, var get shine. What is this? Let's go check our flag IDs. What's the flag ID here? 147. Here it is. Blue coin, shine number 2 collected. Why is this here? Well, actually what this is the ID of the shine that was in our level. And what we want to make sure is that once Mario collects the shine, it no longer decrements the coins, because if you don't have this check in here, it essentially means that Mario will get the shine, he'll be in his shine grab animation, but his coins will still be decrementing. And what it actually means is he can die in the middle of his shine get animation. So this is important to make sure he doesn't die. Again, this is something I found out just by playing the level, seeing what happens. You don't sort of program it in one go, you do iterations and see which parts work, see which parts break. Okay. If coin is less than 1, if Mario has reached 0 coins or less, again I like to do the less than because it's possible, it's not really possible, but what if the coin was -1? You don't want to do coin equals 0, because if the coins were -1 he should still be dead, so you want to do less than or equals 0, or just less than 1, like I did. What was that? Okay. Stop BGM, we need to stop the background music, and if he has less than 1 coins we need to kill him. And then we break, which ends the script, and yield, of course, always yield. Technically not necessary because we yielded up here, but still good to have, so make sure you always do that. And that's it. So that's how you do that. That's all the Sun script. I know it was a bit long, but a bit of an in detail guide, and hopefully this helps. We might cover some more script in the future. I think this is quite in depth, so perhaps we'll leave it there. Let me know. Okay, once you've written the script, how do you get it into the game? Let's take the script we made earlier and let's copy it over here next to this bat file. So we've got these 3 bat files. So what do they do? This one compiles the Sun file. So this is the main one you're going to use, and it turns the .sun file into a SB file, and that is a file that can be loaded into the game. What are these other 2? Decomp and disassemble. Well, I wrote a little disassembler for SB files, and if you have one that's in the original game, so let's go find one. Let's go extracted levels. Here we go. Let's go into the casino. This probably has one. SP talk event. Okay, let's take this, and then we can drag it over here. Let's decompile it. So what this does is it creates this decompilation of the main text, and it converts it back into readable stuff. It doesn't get it quite right, so you need to always make sure you understand how each one works, but that's how that works. What about this other one, disassemble? Let's try that. Disassemble. And now we get the actual sort of, not really machine code, but sort of byte code rather, I'd say, that the actual game sees. So this is what the game sees, and this is why you need the compiler. The game doesn't actually see the script file, it sees this stuff. This is kind of useful, but if you really want to see how a script works from inside the game, if you want to know how a certain thing is done in the game, probably better to decompile it. But again, take that decompilation with a grain of salt because it doesn't quite work. Okay, so the one we want to do is compile it. So let's compile it. Okay, we've got the SB file. Now where would we put that? So we go into our level folder, we go into scene, we go into map, we go into SP, and we copy paste. I've already got one here. Another side note is you can actually have multiple scripts running in tandem. So you can have as many scripts as you want in the game. Just copy them all in here and they'll all run. So that's quite nice. I changed the game's code so that Mario's momentum wouldn't stop when he hits the ceiling. And one side effect of this is that you can now actually do these block breaking things. In the original game there's a sequence like this, but it doesn't work quite as well because you just get stuck as soon as you hit the block. So I think that's a pretty major improvement. These rails are like the boat rails, except they also have parameters to control the rotation of the block. This level's all based around wall jumps, so the way you're meant to do this is just a single wall jump here. But if you want to get the 1-up, the intended way at least is to do something like this. You aim it a little bit more inwards, and then you can get the 1-up. 1-ups in this game are completely useless, but find that people still want to get them, so I put them in as an extra challenge. The blue coin used to be hid under that sign, but I didn't really like that location, so I moved it all the way up here. The intended way to get this thing, I'll show you. You just jump out and you drift back in, like that. It's kind of technical, but since the blue coins are optional, I don't mind setting more technical challenges for the blue coins. I always try to get one timed red coin mission in every level, in every world. And in each one I would try and test people on all the skills they've learnt so far. So for this one, I wanted to test them on the rotating platforms and these spinning platforms up here. Also I've got these ice blocks which I introduced in the earlier one. Whoops. Those are the normal blocks that were reskinned to look like ice blocks, so you can't actually melt them. I tried to get all of these rotating platforms to cycle on different speeds, which means that one of them is probably going to be quite close to coming down to your level. If they were all at the same speed, then they'd either all be up or all be down, and you'd have to wait much longer for each platform. Also, on this level, I expanded the hitbox like I did on the other levels, so you see that coin, I grabbed it even though I barely touched it, and that's because if you expand the scale of a coin, the visual model will stay the same, but the hitbox will be much bigger. This blue coin also has a bigger hitbox. Or does it? No, it doesn't. It does not have a bigger hitbox. It should have a bigger hitbox, but it doesn't. In fact, this demonstrates my point quite well. That it's actually quite hard to judge the depth. Am I over it? I think I am. Yeah. Cool. This level is the first in the game to include Yoshi. So I had to make sure that the fruit was correct, and normally in the game the fruit is decided randomly, which is a problem for me because I didn't want to have to put every single fruit in this level, and I'll explain why in a bit. But essentially what I did was I went into the DOL, and where it decides to which fruit Yoshi wants, I just set it so that it's always bananas. So you'll actually notice that every Yoshi in Arcade wants bananas, and that's the reason why. Now, the reason I had to have it as a banana is because each fruit has their own properties and their own throw lengths, friction on the ground, and how far they roll. So, to make this throw perfect, and so that it was actually easy to do consistently, I had to make it so that it was a banana, because it doesn't throw too far, and also it doesn't roll that far. Pineapples roll ridiculously far. Peppers, you can barely throw them, but they don't roll as much either. So I think banana was a good middle ground. And the best way to do it is to just jump and throw it. Or not. What? Why didn't that work? Okay, let's try a little throw. Here we go. Attempt 2. Why isn't it throwing? I think I have to jump forward and throw it. Like that. Yeah, there we go. Oh, come on. Stop. Yes. See, that's a good thing about bananas. They don't roll as much. So that's why I chose them. And that's why I wanted Yoshi to always want the banana. Otherwise, half the time you'd be kind of screwed over. Well, that's all for today. Tune in next time for a look at Rico Harbor. See you then.